This is Professor Pelton. This is part 4 of chapter 3, section 5. So now we're going to do the horizontal stretching and shrinking. So now we're multiplying by a scalar in the inside of the grouping symbol, whatever that grouping symbol happens to be. And if that number is greater than 1, you're actually shrinking. And if it's between 0 and 1, you're actually stretching. So it's always counterintuitive in the inside of the grouping symbol to what you actually think. So it only affects the x value, not the y. Okay, so let's take this arbitrary function that I've made and do a f2 of x. So thus we're affecting the x value only, and it's actually a shrink by 2. So if I look at my table here, this is x and y. Okay, so I'm affecting half the 4, or half the negative 4 becomes negative 2. So it becomes negative 2, 0 is the coordinate. Negative 2, 0 will become our coordinate. Okay, so the next coordinate is negative 2, 4, and the only part of that is x is the negative 2. So if I half that, I get negative 1, 4. Okay. It's supposed to be negative. I'm not quite getting that in there. There we go. Okay. So the next one is 0, 0. Well, if I half of 0, I still get 0. I didn't go anywhere. So that's 0, 0, essentially. Okay, so that first part is like this. All right, so the next part I get a 2, negative 2. Well, half of 2 is 1, so we are at 1, negative 2. So we're at 1, negative 2. And lastly, we have 4, 0. So the only part that's x is the 4, so that gives us 2, 0. Okay, so again, what I'm trying to dictate here is this only affects the x, and it's counter to what you think it is, right? So multiplying by 2 is actually a shrink horizontally. All right, pause the video, try the student problem. Okay, so same arbitrary function that I made, but this one is either dividing by 2, because this is the same as saying f of x over 2. So either dividing by 2 or multiplying by half is the same thing. Either way, it's actually a stretch by 2. So if I take my x and y values, so I'm actually multiplying by 2, I get negative 8, 0. So negative 8, 0 is right there. Okay, so my next coordinate, x, y, it's only a negative 2 for the x. So if I double that, I'm going to get negative 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. I'm right here. So I'm negative 4, 4, because I only changed my x value. So my next coordinate is 0, 0. But multiplying anything by 0 remains 0, right? So I get a 0, 0 coordinate. So that's the first part of the function here. Okay, so the next coordinate is 2, negative 2. So if I double the x value, I get 4, negative 2. So 1, 2, 3, 4, 1, 2. So 4, negative 2. Okay, and then lastly, we have 4, 0. So x is changing from 4 to 8 because it's doubling. So we're going to be right here. We get 4, 0. Okay, so we're noticing in all cases, well, there's translations, scalings, reflections, it only affects either x or y, but not both. Okay, so let's do multiple all at the same time. Or actually, no, I'm sorry, these are just the horizontal and vertical, stretching and shrinking algebraically. Okay, so let's take the f of x function and shrink by a factor of 3 horizontally. Okay, so that's f of 3x. It's horizontal, so it's in the inside, affects the x, and it's counterintuitive, so I'm going to multiply by 3, not divide. Okay, so I'm going to have absolute value of 3x minus 3, absolute value minus 5, because I'm replacing x with 3x. So therefore, my new function, which we're calling g, g of x, is the absolute value of 3x minus 3, absolute value of minus 5. Okay, so the next one we're going to stretch by a factor of 2. So that's going to be 2 times f of x, because it's vertical, so it's going to be on the outside. And those ones are straightforward. You multiply by 2 to stretch, divide by to shrink. So this is going to be 2 times the absolute value of x minus 3 minus 5, which is actually wrong because it has to be times the whole thing, right? It's a big mistake. So make sure you're doing that in all these cases. You're including the entire function, not just part of the function. So the new function g of x is actually 2x minus 3, and then minus 10. Do not distribute over absolute values. Do not distribute over absolute values. Are not parentheses. Cannot do that. Order of operations. All right, pause the video. Try the student problem. Okay, so I'm going to horizontal stretch by a factor of 2. So I'm going to stretch by a factor of 2. That gives me h of x over 2, because horizontal is x on the inside, and it's counterintuitive, so I'm going to divide by 2. Okay, so it's 5 times the x over 2 plus 1 minus 2. Okay, so we can simplify here. So we get what? A new function called p of x, which we're going to call 5x over 2 plus 1. You can do 1/2 x also. Same thing either way. It's really your preference. So if I'm going to vertically shrink by a factor of 3, and you do 1/3 of h of x, right? Since it's vertical, it's on the outside. So I'm going to do 1/3 times the 5x plus 1 minus 2, right? The whole thing. So my new function p of x is 5/3 x plus 1 minus 2/3. Okay. All right. So lastly, what if we do more than one transformation? Unless it specifies to do them in a certain order, typically you have to do them in the correct order of operations. If we go back to the original first page of the notes, you'll notice that the order is given. So unless otherwise specified, you must follow the order. So the order right here, which is on page 22, is horizontal translation, stretching and shrinking, reflecting, and then followed by vertical translation. The reason being horizontal translation is parentheses, and vertical translation is adding and subtracting, and of course stretching and shrinking is multiplying and dividing. So that follows the order of operations essentially. Okay, so let's go to these last couple problems here. Okay, let's say we have a very basic function of x, and we want to translate 3 units up, and we want to vertically shrink by a factor of 0.25. Well, the vertically shrinking, or shrunk past tense, right, happens before the translation. Okay, so I'm going to do 1/4 of f of x first, because that is right, a vertical shrinking, and 0.25 is a quarter. Okay, so that gives me a 1/4 of x. And then I want to translate 3 units upwards, so that's f of x plus 3, so that gives me 1/4 x plus 3. So we're going to call this new function g of x. So g of x is 1/4 of x plus 3, if I do them in the proper order. Okay, pause the video, try the student problem for yourself. Okay, so according to the student problem, we're taking the absolute value function, we're reflecting over the y-axis and translating 2 units to the left. With translating 2 units to the left comes first. So that's f of x plus 2, because the inside plus 2 moves left 2. So that gives me the absolute value of x plus 2. So reflecting over the y-axis comes second, which means I'm changing the x value, so that's f of negative x. Right? Because if I change my x, I go over the y. So that gives the absolute value of negative x plus 2. So my new g of x function is negative x plus 2 absolute value. Okay? That is the end of part 4.